Okay, one. Later. May na. Okay. Oh. So last time we talked about how to solve the system of linear equation. Okay. Okay. So using the Gaussian elimination, and we know that Gaussian elimination by using the structure of the matrix, which is called the upper triangular matrix. Since if we have the upper triangular matrix, we will be able to find the solution easily because we can use what we call the backward substitution. Okay, so today I will give you the example and show you how we use the Gaussian elimination to solve the system of equation. For this one in class, I will teach you only 3 by 3, but the algorithm can be extended to maybe 10 hundreds, 1,000, 10,000, the biggest size of the matrix, okay? But it's gonna be the same systematic ways to do it, okay? So I will start with the example by writing the system of linear equation a2x1 plus x2 minus 3x3 equal to 0 minus x1 plus x2 minus x3 equal to 2. x1 plus 5x2 equal to 3. If we have this system of linear equation, we can write down in terms of augmented matrix. I will have 2 minus 1, 1, 1, 1, 5, negative 3, negative 1, 0. And the right hand side is 0, 2, and 3. Okay. For now, we will try to make it this matrix. The matrix on the left hand side is, we can call this full matrix. Okay, we can call it as a full matrix. Even it has some zeros, it's okay. All right. So now what I try to do, I will mark this as my pivot. Now I will try to make this thing equal to 0, this equal to 0. Okay. I will copy. I use this notation represent equivalent. Okay, equivalent system. Now, what I want to do, I want to make the element below 2 equal to 0 and 0. Okay? How can we make it equal to 0? I will take every element in row 2, subtract by the same thing, which is -1, right? How can make it equal to -1 by using row number 1? I divided by 2. So this element will be 1. The pivot will be 1 by divided by 2 is 1. And we want it equal to -1. So I multiply this by -1. And in the future, we will call this as multiplier M1, 2. Okay, M come from multiplier. Okay. Now row number 3 is calculated R1 divided by 2. We want it equal to 1, so you will multiply by 1. Okay, we take the values there. Now we calculate this. How can we get this? We will take 1 plus 1 over 2 times 1. Okay? And -1 plus 1 over 2 times -3. And 2 plus 1 over 2 times 0. Okay? For this one, this for this, this. Okay? We will take 1 plus 1 over 2 times 1. And then we will get 3 over 2. 1 minus 3 over 2 is -5 over 2. And this is 2. Okay. Now I get consider the third row, okay? The third row. I will take 5 minus 1 over 2 times 1. 0 minus 1 over 2 times -3. 3 minus 1 over 2 times 0. 3 over 2. See? Now I have this matrix. When we have this, we will mark this as the pivot element. Okay. Our matrix will be reduced to one size lower. Okay. And then we want to make this element equal to 0. How can we make the element below the 3/2 equal to 0? Okay, now we look at this as the pivot element. So we will say that R3 subtract by R3 divided by the pivot, which is 3/2. And what do we want? We want equal to 9/2. Okay, which is the same as R3 minus 3 R3. Yeah. Minus 3 R2. Okay, because we want to get rid of 9/2. We try to make 3/2 equal to 9/2. So just straightforward, we divided by 3/2 and we want 9/2, we multiply by 9/2. Okay, keep in mind that computer does not smart like us, okay? Computer doesn't smart like us. Even the metric is 1, 2, 3, 0, 1, 1, 2, 3, 4, and so on, okay? For us, we will skip the second row. But computer doesn't know that is 0, right? Because it's gonna have the pointer pointing to the array of the matrix that we have. It doesn't know, it cannot see that, oh, 0 is there. We skip the second row. They will not do it. They will go sequential, do one by one by one. Okay, so this one is going to be R2 minus R1 divided by 1 multiplied by 0, which means this step is still there. This step is still there, even it is 0 already. Do you get my point here? Computer doesn't know that is 0. It's not even, it's not that smart, okay? It's not that smart unless you train it very well that, okay, you recognize this 0 there, you skip it, but there's more complicated things to do. But so this is the sequential machine, so you do it in the same procedure. Even if 0 there, you use it. You still go through the same process. Every element in the row, okay? For us, we might write it down directly because we can see and we know that 0 is there, okay? Now, R3 minus 3/2 R2. So it is R3, which is 3/2 minus 3 times R2. R2 in the same column is 5/2. The last column, which is 3 minus 3 times 2. Okay. What is it? 3 minus right? Plus, right? Should be 9, right? Sorry, thank you. Okay, so it's plus Now we have upper triangular matrix, right? So now we be able to solve the system. So we have backward substitution. We get 9 times x3 equal to minus 3. This gives you that x3 is minus 1/3. And then we have 3/2 x2 minus 5/2 x3 equal to 2. This after you substitute, you get x2 equal to 7/9. And then the first equation gives you that 2x1 plus x2 minus 3x3 equal to 0. You plug it in x3 and x2, x3 here, x2 here. So you solve for x1, you get x1 equal to 8/9. Okay? So this is just the procedure. You have two steps. The first one, you write down from the system of linear equation in terms of augmented matrix. Once you have augmented matrix, you try to read it in such a way that your quotient matrix is upper triangular matrix. Okay? And after that, you have upper triangular matrix. You use backward substitution algorithms to find the value from x3, x2, and x1. Okay. So this is systematic way that you do it by hand, and then after that you will use your slave. You write down the code, and the program computer will do it the same things that you assign to do over and over the time. Okay, so you have your label nowadays. In the old days, they don't have the calculator, right? Have I ever showed the picture of the NASA when they do the calculation? I love to show. Let's see if I be able to find. I like this picture. Okay, I want to show you like in the old days when they do the computation, they need the big board for this is from the NASA, so they do the calculation. You have to have the ladder, you have like chalk and board, this is the way, this is the way that they do the calculation on the board. Okay, so I think it's very classic. Okay, and I don't know if you guys have seen or gone through all this picture, but this is my favorite picture that I want to share with you. Okay, that this is quite amazing that how people work together in the old day. Okay, so all right. Okay, so now I want to give you example of the 2x2 matrix. Okay, 2x2 matrix, and then we will use the same procedure by using Gaussian elimination. If I have the problem like 0.0003x plus 59.14y equal 59.17. Okay, and 5.291x minus 6.13y equal to 46.78. Okay, suppose you do this by hand. Okay, no calculator, and you will use only 3 digits. Let's see how many digits I want to use. I will use only 4 digits. 4 digits. For example, this means 4 digits. You have the number after this one 4, this one 1, 2, 3, 4. Okay. I want to use only 4 digits. For here it is like 6.13. Actually, you can put 0 at the end. Okay. This one is 4, 4, 4. Okay. This is just the rule. So this will be the example of you have finite digit for the computation in the computer. Okay. But this one is going to be example which is very, very classic that we want to tell you something. I will tell you at the end, okay? After we do this calculation. Okay. So now I will write this in terms of augmented matrix. You please feel free to use your calculator and tell me only 4-digit number, okay? 4-digit number. 0.00 every single step, okay? We will use only 4-digit. 291 minus 6.13. I can add 0. On the right hand side, we get 59.17, 46.78. Okay, so the first row. The first row remain the same, right? The second row, I want this 0. To make this 0, I have to use R1 minus, R2. Okay. R2 minus something, R1 divided by 0.0003. And you want it equal to 5.291. Okay? So if you do this calculation, I want you 3 digits. The whole digit is 17636.66. Okay? And if I say I will use rounded to 4 digit only, so my value is going to be 176. I round this up to 40. Okay. Show only 4 digit that has the significant that can show the number. Okay. 17640 or 0.1764 times 10 to the 4th. Okay. So if I write it this way, okay, I'll just write it this way. Now, I want to calculate this star, okay? What is this star? The location at star equal to minus 6 point, minus 6.130. Subtract by 0.1764 times 10 to the 4th, multiply by R1, which is 59.14. What I have to do, I have to do this multiplication first, right? I will get 1043229.6. When I use it for my calculation, this will turn out to be 1043. Okay. Since I want only 4 digits, so you have, let's see, -1. So it's about, okay. Yes. The what? Hmm. Yeah. Right. Okay. So if you have this one, subtract by this one, you will get approximately, yeah, because this one is large, okay, because this one is, this one is quite large, subtract by just 1 digit here, so it's not effect, okay. So I get this one, okay. Now let's see, how about this yellow star? It's gonna be 46.78 minus 0.1764 times 10 to the fourth multiplied by 59.17. Okay. I'm sorry, actually it should be too many. Sorry. So if I here, okay, so I changed back, okay? I forgot I multiplied by 10 to the 4 and put only 3 zeros at the end. So this is gonna be this one 0.96. So it's gonna be 0.1043 because here after 3 is 2. Okay, so it's 1043. And here, if I want to use only 3 digits, the number after 3 is 7. So I round it up to 4. Okay. About minus 0.1044 times 10 to the 6. Okay, now. So we will have the values for y, right? So the star is actually this part. So the equation to solve for for y, we have 0.01, no, sorry. 0.1043 times 10 to the 6 y equal to minus 0.1044 times 10 to the 6. So y is about 1.001, right? You have 1044 divided 1043 is this one will be minus, right? Minus, I forgot minus sign, okay? So minus divided by minus is plus. Okay, actually, if you do the actual division, you will get from my calculator, you get 1.00095. But if we round to 4 digits, we have 1.001. Okay, 1.001. This is y. So for x, let's see how to solve for x. X, you're gonna have what? This equation. This equation. I will find x. X gonna be equal to 59.17. Subtract by 59.14 multiplied by y, which is 1.001. And then divided by 0.0003. Okay? And now this multiply this is 59.1914. So I will use only 59.20. Okay. So you will get 59.17 minus 59 0.20 equal to minus, on the top you get minus 0.03 divided by 0.0003. So it's about minus 10, okay? Hundreds. ถูกไหมเนี่ย I made a mistake in my book. Equal to minus 100, okay? So x is, for this problem, x is minus 100, y equal to 1.001. Okay.
But I have one that I don't know you.
Oh, okay.
But
Can borrow.
for
Yeah.
this one,
Oh, I don't think so. Oh, no. Yeah, it's okay. Quiz, maybe.
Okay. All right. I don't know. Now, what I want to ask you guys to help me to do this calculation. Okay. For this one, the same problem. We know that from what I taught you that the intersection point of the two lines always intersect at one point, right? For this one you have the solution. And it doesn't matter how you call it, you call this as equation number 1, this as equation number 2. It doesn't matter if I will write down equation number 2 first and then equation number 1, right? So I will paste here. And now I will swap. I will interchange. This is what I copy. Yes. Oh. This is what I copy. Sorry. Copy from the previous problem. Okay. Now I will move this equation here. Okay. Now I redo it again. I redo it again. Okay. My equation, my augmented matrix like this. Okay. Let's do it one more time. Can you help me, please? Okay. This is no. This is not right. This one. Again. I guess, but you remember the old one. Okay. Okay, so now this is the pivot element. Okay, I will make the matrix, the one below pivot element equal to 0. Okay, 0. So the R2 minus R1 divided by 5.291 multiplied by 0.0003. Okay. And this is okay. So it okay. So this number. So I will use 0.0001. Okay. Because this number greater than 5, so I round up to 1. So the values at the star location is equal to 59.14 minus 0.0001 multiplied by minus 6.13. So this is gonna be okay. So it's gonna be around 59.14 minus 0.0006, which is 59.14 minus 0.0006 is 59.1394. So if I use 4 digits, so this is gonna be 59.14, okay? And the yellow star equal to what? Equal to 59.17 minus 0.0001, which is this number multiplied by 46.78, okay? It's gonna be about 59.17, okay? because this multiply this is 0.00461 so I use only 0.0046 so you have 59.17 subtract by 0.0046 is 59.1654. I use 2 digits, so it's round up to 59.17. Okay. Now I will get the star is mean your matrix, okay, will turn out to be equivalent to this one. 5.291 minus 6.130, 46.78, 59.14, and 59.17. So I will get 59.14y equal to 59.17. So y is 1.001. Okay. 59.17 divided 59.14. You get the real one if you use so many digits, okay, 0, 0, 0, 5, 0, 7. So if I want to use 3 digits, this is 5, so I have 1.001, okay? And for x, we get 5.201 minus 6x. 5291, right? Minus 6.130y equal to 46.78 x, so x is 46.78 plus 6.130 multiplied by 1, which runs 001, and then divided by 5.291. Okay. What I need to do 6.130 times 1.001 is 6.13613. So you will get 46. Let's see. All right. 46.78 plus 6.136, 52. 52.916 divided 5.291. So you get 52.92 divided by 6.130 times 1.001. Okay, so x is 10. Y is 1.001. This is 2. Okay, I can remember that for 1. Not the same. Okay. From problem 1, I believe that we do it correctly. Okay. Because you help me check, right? I ask you guys to help me, okay? We check. This is what's gonna happen if you do it by hand in the old day. You do it. You check it first to get number 1. You get x is minus 100. And I swap the 2 equations, right? Normally we say, okay, it doesn't matter which one you call number 1, which one you call number 2. Intersection point always be the same. But now I have problem number 1. Okay. Problem number 1, you remember that point 0003 is on the top, it's called the first one. And then system number 2, I have 5.291, the second one. The first one, okay. I have system number 1 and system number 2. The difference between system number 1 and number 2 is only I swap the equation. I either change the equation. I do the same procedure. I'm sure that we didn't make a mistake, okay? For both of problems. And I came up with different solution. Okay. So you guys want to redo it again? So who you gonna choose? If I ask you to choose 1 or 2, why? You always think that, okay, your first decision is gonna be the correct one, right? And someone say, okay, I choose number 2. Actually, number 2 is correct one, okay? Actually, the number 2 is correct one. Why you think that the number 2 is the correct one? Okay. Okay. So the number 2 is correct in the sense that this problem we constructed from the problem which we just assume the solution first. Okay. Suppose we construct from problem number 2. Okay. I constructed the problem from, suppose that I know that x is 10, y is 1.01. Okay. I multiply that and give it the right hand side. Okay. So the exact solution or the real solution is x is 10, y is 1.01. But we did not make any mistake. We did not make any mistake in number 1. Okay, the problem. But the fact that if we work in the real system, the theoretically it will be the same solution, the same point. Graphically, you have equation number 1, equation number 2 is this is 1, this is 2, or you care for this 1, this 2. It doesn't matter in real life, okay? But when we do this calculation, we did only finite digit. Keep in mind that we did it in the finite digit, means we use only 4 digits. This is just extreme example to show you that interchange the order of the equation, the step is very important, okay? I will explain you more, okay? Suppose you have some values, 0.0003. I have the number 0.003. If I multiply 0.003 by something which is like 10, the values of 0.003 gonna be what? 0.003, right? Is it bigger? It's bigger, right? When you multiply by 10, it gives you the bigger number, the larger number. This is bigger. If I multiply by 0.1, what do I have? 0.0000. I would like to tell you that we can think about this and the multiplier. This multiplier, if it's greater than 1, for example, is 10, is 5, is 3, it will increase the values of the one that you do the multiply this number to, right? It's increase the value. It's make it bigger. But if you multiply by something as the fraction, the value is decreasing, smaller. This is we will use with the computation, because when we do each step of the calculation, we have something which is called error, because we have round off error, right? By substitute the real number into the computer number. You have, even it's a small number, as I told you that like the Patriot, the golf ball, right? That Q28 soldier. By the digit, the very small number, when it's multiplied, is add up, it can be big. And that can cause the mistake in the computation. So the things that we try to do is we try to control the error. So whenever we do the something multiplication, we try to avoid the large number. We try to avoid the multiply by something larger than 1. Because when you multiply something larger than 1, the size of the error is increasing, okay? It's increasing. So let me show you the number that I boxed. This number, okay, it's large. It's larger than 1. It's larger than 1. That make this multiplier large, which is not good. Because if you have small error, you multiply by the large number, the error increased. But here, multiplier is small. You have the error, and then you multiply by something less than 1. So this is called the multiplier, which is you want it to be in such a way that is less than 1. Okay. So this introduce you to what we call the Gaussian elimination with partial pivoting. So this method, we will try to control the multiplier so that the multiplier will be something that be the number that less than 1, okay? So I give you example. 4 by 4, okay? Suppose if we do this just straightforward, in some time we call it naive Gaussian elimination, is mean whatever the matrix we have, we just directly calculate from this matrix, okay? And we have the pivot element as number 1 here. I want you to see that if I want to reduce this matrix to upper triangular matrix, okay? I want you to show the multiplier only, okay? I'm gonna make the column number 1 after my pivot element to be 0, okay? So let's look at the multiplier. To make the second row 0, you can first column of the second row. So you have R1 divided by 1 multiplied by 2. For R3 minus R1 divided by 1 multiplied by minus 1. R4 minus R1 divided by 1 multiplied by 3. This is your multiplier. You see? Greater than 1, right? But if you look at this one, if you swap the largest number to the first row, so your pivot element will be 3. Okay, if you swap this to the first row. Okay, let's see, 6 minus 9 minus 11. So if you do this, you want something underneath number 3. This to be 0, okay? 0, 0. What is gonna be your 2 minus 1, 1, okay? Your multiplier will be what? R2 minus R1 divided by 3, right? So multiply by 2. R3 minus R1 divided by 3 minus 1. And R3, R1 divided by 3 of 1. 1 over 3, okay? So you can see that the multiplier here, less than 1, less than 1, less than 1. Okay, so that's what we will talk about it on Tuesday. Okay, next Tuesday, that we will look at the first column, look at the maximum element. If the minimum element is in the fourth row, you swap the first and the fourth. Okay, so you take it up and you swap the row. The first one gonna come back to the fourth row, and then that will guarantee that your multiplier is less than 1. Okay, then your multiplier less than 1 is mean that you can control the error, because you can imagine that if you have 100 by 100, okay, 100 by 100, the first one, if it multiplier greater than 1, suppose it's be 10, you will reduce it to 99. Second one is multiplied by 2. Third one may be multiplied by 0.5 or whatever, but this can be large number. If you do it multiply, every time you have to do multiplication, right? Add and subtract and multiply by the larger number. If you not control the multiplier, when your metric is large, this will cause a huge problem, because your error add up. Okay, you build up the error, so this will give you the uncertainty, the wrong solution. The computation, you every time you have to control the error. That is the most important of the approximation and the calculation. Okay, so I will see you guys on Tuesday. Okay, and someone sent me the message, want to see the exam. Follow me to my office. Okay, and again, if you want to pass this course, is 50%. Okay, 50%. I did not tell you the average is quite high. Okay, but you have to think yourself if you be able to pass 50 only. Okay, so yeah, if you want to get a 80%, pass 50%. This course open only once a year. I'm not sure next semester, next year, gonna be the second semester. I'm not sure yet about the first semester.